Welcome to tonight's journey through the cosmos. The moon, where we rested in theoretical habitats, is now behind us, a grey crescent beside Earth's blue sphere. We're boarding a Mars transfer vehicle in lunar orbit, a spacecraft designed for the 6 to 9 month journey across interplanetary space. This is not speculation or future dreaming. Tonight, we treat this Mars mission as present reality, an operational voyage already underway. Settle into comfort as we begin humanity's greatest journey. The docking corridor connects the lunar shuttle to our Mars-bound vessel. White walls curve around you. Handrails guide movement through gentle microgravity. Through small windows, you glimpse the spacecraft ahead, a long central spine with habitat modules, propellant tanks, and solar arrays extending like wings. This vessel will carry us 225 million kilometers across space. It waits with patient readiness, systems humming quietly, prepared for departure. You float through the adapter into the main habitat module. The space opens around you, surprisingly generous. 25 cubic meters per person, the psychological minimum for long-duration missions. Other crew members move calmly through the corridors, securing equipment, checking displays. Everyone's movements are deliberate, professional, relaxed. This is home for the next 259 days. Large observation windows show the cosmos beyond, stars burning steady in the absence of atmosphere. The spacecraft itself represents decades of mission planning. NASA's Mars Design Reference Architecture, SpaceX Starship concepts, Mars Direct proposals from the 1990s, all converged into this functional design. 400 to 500 metric tons at Earth departure, of which 150 to 200 tons will reach Mars. Propellant tanks hold the fuel for trajectory corrections. The Mars descent vehicle waits at the far end, dormant, its moment months away. You settle near an observation window in the common area. Earth fills the view, brilliant blue and white, swirled with cloud patterns. The moon curves grey and ancient beside it. Both worlds where humans have walked. Behind them, barely visible as a reddish point, Mars waits. Between us and that distant world, 225 million kilometers of space stretches ahead. The journey begins soon. Very soon now. First, we must understand why we launch when we do. Earth and Mars orbit the Sun at different speeds and distances. Earth races along its path at 29.78 kilometers per second. Mars travels more slowly, 24.07 kilometers per second. They align favorably for efficient transfers only once every 26 months. 779.94 Earth days, the synodic period between launch windows. We cannot go to Mars whenever we wish. We wait for orbital geometry to permit it. The distance between our worlds varies dramatically. At closest approach, called opposition, Earth and Mars pass within 54.6 million kilometers of each other. At farthest separation, during conjunction, they lie 401 million kilometers apart, a 7.3 to 1 ratio. This variation makes launch window selection crucial. We don't aim for where Mars is now, but where Mars will be 8.5 months from now when we arrive. Orbital mechanics demands patience and precision. The trajectory we'll follow was calculated a century ago. Walter Hohmann, a German engineer, published his transfer orbit mathematics in 1925. His book, Die Erreichbarkeit der Himmelskörper, The Attainability of Celestial Bodies, the Hohmann transfer orbit remains the minimum energy path between planets. 259 days from Earth to Mars. Not 258, not 260. The mathematics are patient and exact. We follow the ellipse Hohmann drew on paper before rockets existed. This transfer orbit has specific geometry. Its perihelion, the closest point to the Sun, lies at 147.1 million kilometers, Earth's orbital radius. We leave from here. Its aphelion, the farthest point from the Sun, reaches 227.9 million kilometers, Mars's orbital radius. We arrive there 8.5 months later. Between departure and arrival, we coast along this elegant ellipse, engines silent, momentum carrying us across the solar system. Our departure requires precise velocity change. Delta V, the fundamental currency of spaceflight. 3.6 kilometers per second added to our speed relative to Earth. This trans-Mars injection burn will push us onto the transfer trajectory. The total mission Delta V budget from low Earth orbit to Mars orbit is approximately 6 kilometers per second. 3.6 for departure, 2.4 for Mars capture, plus margins for course corrections along the way. Every meter per second costs propellant. Every calculation must be exact. A quiet tone sounds through the habitat. 5 minutes until engine ignition. You secure yourself near the window, hands gripping padded restraints. The view shows Earth and Moon, steady and bright. Crew members float to their stations, calm and focused. This is not a violent launch from Earth's surface fighting gravity. This is patient acceleration in the void. We're not fighting anything. We're negotiating with orbital mechanics, asking permission to leave Earth's embrace and transfer to Mars. The countdown reaches 0. The engines ignite. Not with thunder, but with steady pressure. You feel weight return, gentle but persistent. 0.2 G, maybe 0.3. Enough to remind you which direction is down. The spacecraft is accelerating, adding 3.6 kilometers per second to its velocity over the next 12 minutes. Outside, in vacuum, there are no flames, just the invisible push of superheated propellant streaming from thruster bells. The burn is calm, methodical, exactly as planned. Through the window, the stars begin shifting position. Slowly at first, then more noticeably. We're turning, orienting for the trajectory ahead. Earth and Moon slide across the frame. The acceleration presses you gently into the restraints. 12 minutes of this steady push. 30 to 40% of our propellant mass will be consumed in this single burn. This is the largest velocity change of the entire mission. After this, we coast. Minutes pass with quiet persistence. The engine burn continues without drama. Displays show velocity increasing, trajectory parameters converging on planned values. The flight controller's voice is calm, reading numbers, confirming nominal performance. Earth rotates slowly in the window. We're leaving. Not quickly, not violently. We are leaving with mathematical precision, following Hohmann's century-old calculations, joining the trajectory that every Mars mission has followed. The engines cut off. Weight vanishes instantly. You float free again, still holding the restraints but no longer needing them. Silence returns. The deep quiet of space broken only by the gentle hum of life support systems. The burn is complete. 11.3 kilometers per second relative to the Sun. We've matched Earth's orbital velocity, then exceeded it with hyperbolic excess. We're on our way to Mars. The trajectory is set. In the hours after trans-Mars injection, Earth begins to recede. The change is subtle at first, but measurable, undeniable. After one day, Earth lies 300,000 kilometers behind, farther than the Moon orbits. The planet that has held humanity for 300,000 years is shrinking. After 3 days, 1 million kilometers of distance separate us. Earth has become a bright star with visible blue color. The Moon is a gray point beside it. After a week, both merge into a single, brilliant light in the darkness. This journey has precedent. We're not the first to follow this path. Mariner 4, launched November 1964, flew past Mars after a 228-day journey. Viking 1, 1976, took 304 days to orbit and land. Mars Odyssey, 2001, completed the transit in 200 days. Curiosity rover, 2012, traveled for 253 days. Perseverance, 2021, just 203 days. Every mission validated the mathematics. Our human mission simply scales up the payload. The spacecraft systems work around you with quiet efficiency. Life support begins its long task of recycling everything. Water from breath, from sweat, from washing, all recaptured and purified. Carbon dioxide exhaled by 6 crew members, scrubbed from air and converted back to oxygen. The Environmental Control and Life Support System, ECLSS, must recycle 95% or more of resources. 15 tons of consumables would be needed otherwise. We carry some reserves, but mostly we trust the recycling, the closed loops, the elegant engineering of sustainability in void. Solar panels track the sun with slow precision. At Earth's distance, they receive 1,368 watts per square meter. As we travel toward Mars, sunlight intensity will decrease. At Mars distance, only 589 watts per square meter, 43% of Earth's intensity. The arrays are sized for this variation. Large wings extending from the central truss, catching photons, converting light to electricity. Power flows through the habitat, running computers, lights, pumps, heaters, all the systems that make this vessel alive. You float through the habitat, exploring your temporary home. The corridor curves gently, following the cylindrical module's shape. Handholds every meter provide guidance in microgravity. Crew quarters line one side, small private compartments with sleeping restraints, personal storage, a window if you're fortunate. The common area ahead features a dining table with magnetic meal trays, laptop screens for Earth communication with acknowledgement of delay, exercise equipment with harness systems. Everything is designed for long-duration living. Functional, but comfortable. Thought through. Communication with Earth continues, but with growing delay. Right now, signals take approximately 5 minutes to cross the distance one way. 10 minutes for a conversation to complete, question and answer. As we travel farther, this delay increases. At Mars distance, 3 minutes at closest approach, 22 minutes at conjunction. Total round-trip signal time, 6 to 44 minutes. There are no real-time conversations anymore. We send messages, then wait. Earth responds eventually. It's like letter writing, patient and contemplative. The Ka-band deep space network provides 1 to 6 megabits per second bandwidth depending on distance. Sufficient for video calls, though delayed. You record a message for home. Talk about the departure, the engine burn, the view of Earth receding. You send it. 10 minutes later, family responds. They're smiling, proud, asking how it feels to be heading to Mars. You record another message. This is how conversations work now. Asynchronous, patient, perhaps better than real time. You think before speaking. Every word is deliberate. Chris Hadfield once compared Mars transits to historical ocean voyages. 6 to 9 months in a tin can sounds hard, but sailors crossed oceans for years. The difference is we can talk to home every day, even with the delay. He's right. This journey is long, but we're not isolated from Earth, just distant. Messages flow back and forth. Mission Control monitors our systems. We're alone out here, but we're not forgotten. Earth remembers us. Earth waits for our arrival at Mars with patient anticipation. Days pass in gentle routine. Morning begins with artificial dawn, lights gradually brightening in the habitat. Crew members wake, prepare breakfast from stored supplies. Coffee tastes the same in microgravity, though drinking requires careful pouches. Exercise comes next, 2 hours daily. Treadmills with harness systems to prevent bone density loss. 1 to 2% monthly decrease without countermeasures. You run in place, held down by elastic straps, watching Earth through a window, growing smaller day by day. Scientific observations fill the days, photographing Earth and Moon from unprecedented distances. Monitoring solar activity, testing equipment for Mars arrival. The crew works together, 6 humans sharing tasks, sharing space, sharing the journey. Peggy Whitson spent 665 cumulative days in space, more than any American astronaut. She said, "The hardest part isn't being away from Earth. It's knowing you can't go home quickly if needed." Mars crews face this challenge amplified. We cannot turn around. The trajectory is committed. Robert Zubrin's Mars Direct vision from 1990 influenced all subsequent mission planning. He said, "Mars is not impossible. Mars is inevitable. The only question is whether we go in our lifetimes or our children's." We're proving his statement correct. Mars is not science fiction anymore. The orbital mechanics work. The life support functions. The Delta V budgets balance. Mars is inevitable. And tonight, we're on our way, carried by physics and momentum toward the red planet ahead. Two weeks into the journey, Earth has become a distant star. Still the brightest object in the sky besides the sun, but no longer showing continents or clouds. Just a blue-white point of intense light. Mars remains a faint reddish point ahead. Not a disk yet, just a colored star. Between these 2 points we drift through emptiness. 200 million kilometers of vacuum ahead. 20 million kilometers of void behind. We're crossing the ocean of space at 11 kilometers per second relative to the Sun. Yet it feels like floating, motionless. Temperature control requires constant attention. Outside the habitat, the spacecraft structure faces extremes. 121 degrees Celsius in direct sunlight. Minus 157 degrees Celsius in shadow. Multi-layer insulation wraps the habitat modules. Active thermal management pumps heat from sunlit surfaces to shadowed radiators. Inside remains comfortable, 21 degrees Celsius. The contrast between exterior harshness and interior comfort creates security. We are protected. The spacecraft shields us from the void. Cosmic radiation passes through the hull constantly. 300 to 900 millisieverts over the 259-day journey. 1 to 3 millisieverts per day. Water-filled walls around sleeping quarters provide shielding. A storm shelter with additional protection stands ready for solar particle events. We monitor space weather. If the sun releases a major flare, we retreat to the shelter and wait for the radiation to pass. Most days are calm. Most days we move freely through the habitat, trusting the shielding, accepting the exposure as cost of interplanetary travel. The habitable volume becomes familiar over weeks. You learn every corner, every storage locker, every window's particular view. 150 cubic meters total for 6 crew members. 25 per person, the psychological minimum. It's enough. Surprisingly enough. The knowledge that this confinement ends eventually makes it tolerable. Story Musgrave, 6 shuttle missions between 83 and 96, said isolation is mental, not physical. I spent months preparing for each mission in my mind. Mars crews will live the journey long before they board. We're living it now. Mid-course corrections maintain trajectory precision. 3 to 5 burns planned during the 259-day transit, each providing 2 to 50 meters per second velocity change. Small adjustments to refine the arrival corridor at Mars. The first correction comes 3 weeks after departure. Navigation determines we're slightly off target. Engines fire for 40 seconds. 20 meters per second added. The trajectory shifts imperceptibly. In 4 months, this tiny change will position us perfectly for Mars orbit insertion. Precision compounds over time. Mars Global Surveyor, launched 1997, demonstrated aerobraking efficiency, using atmospheric drag for orbit circularization over 18 months. 70+ passes through Mars's thin upper atmosphere. Saved 1,400 kilograms of propellant compared to propulsive capture. Our mission may use similar techniques, or pure propulsive insertion. The decision depends on cargo, timeline, risk tolerance. Either way, we trust the precedent. Robotic missions have tested every technique. We benefit from decades of Mars exploration experience. Buzz Aldrin, Apollo 11 moonwalker, dedicated his later career to Mars advocacy. In his 2013 book, Mission to Mars, he wrote, "I believe Mars is the next frontier, and we have the technology today to get there. What we need is the will." This mission represents that will made real. The technology exists. The orbital mechanics are proven. The spacecraft functions. What remained was decision, commitment, action. Now we're here, between planets, demonstrating that humanity's reach extends beyond Earth, beyond Moon, into interplanetary space. One month into the journey, routines feel natural. Waking, exercising, working, eating, sleeping. All in microgravity, all in confinement, all with purpose. Mae Jemison, former astronaut, leads the 100-year Starship project. She says, "Before we reach the stars, we need to reach Mars. It teaches us to become interplanetary." This transit is that teaching. Learning to live away from Earth, not for weeks or months on ISS, but for years. This outbound journey, months on Mars' surface, the return journey, 2 to 3 years total. We're learning patience. The spacecraft around you hums with patient life. Air recyclers, water pumps, computer fans, all creating a gentle ambient sound. After weeks, you barely notice it. It becomes silence, the background of existence. In actual silence, the habitat would feel dead, alarming. This quiet machinery sound means systems working, life continuing, safety maintained. You float in the common area, reading, watching Mars slowly, imperceptibly brighten in the forward window. Days blend together. Time becomes measured in distance covered, kilometers ticking past. We're 40 million kilometers from Earth now. Ellen Stofan, NASA chief scientist from 2013 to 16, stated confidently, "I'm convinced we'll send humans to Mars in the 2030s. The children in elementary school today will be the generation that goes. Perhaps we're those children, grown. Perhaps this mission fulfills her prediction. Or perhaps we're still waiting. The timeline matters less than the inevitability. Mars missions will happen, are happening. The physics permits it. The engineering enables it. Humanity reaches forward." Communication delays continue increasing. Now 15 minutes one way, 30 minutes round trip. Conversations stretch across time. You send a question to mission control, then move on to other tasks. Half an hour later, the response arrives. You've almost forgotten what you asked. This is normal now. Andy Weir, author of The Martian, researched every orbital calculation in his book. He said, "Real Mars missions will follow these same trajectories. The physics doesn't care about drama, it just is." He's right. The physics just is. We follow it, calmly. "6 weeks into the journey, you look back at Earth. It's no longer the brightest star. Venus has taken that distinction. Earth is second, blue-white and distant. The moon is invisible now, too close to Earth to distinguish. Both worlds merged into one point of light. Home. 60 million kilometers behind and receding. You feel no panic, no grief. Just quiet acceptance. This is the journey. This is what leaving means. Earth waits for our return. For now, we travel. The spacecraft mass has decreased since departure. Propellant consumed in trans-Mars injection. Mid-course corrections. We're lighter now, but still substantial. 350 metric tons, perhaps. Of this, 150 to 200 tons will reach Mars orbit. The rest is propellant for capture, landing fuel, reserve margins. Every kilogram planned for, every system optimized. This is not a reckless adventure. This is careful engineering, proven by decades of robotic missions, now applied to human spaceflight at interplanetary scale. Scott Kelly spent 340 days on ISS during his year in space mission. He reflected, 340 days felt long, but I always knew Earth was 90 minutes away by Soyuz. Mars crews won't have that comfort. They're committed for 2 to 3 years minimum. We feel this commitment now. No escape pod returns us to Earth. No emergency abort brings us home quickly. We're locked into the trajectory. Orbital mechanics gives no shortcuts. We coast to Mars or nowhere. The certainty creates peace. No decisions remain. Only patient traveling. Two months into the journey, Mars begins showing as a tiny disk through telescopes. Not visible to unaided eye yet, but cameras capture it. A small, reddish circle, detailless, but planetary. Crew members gather at the forward observation window. Someone points out Mars's position. You stare, trying to see the disk without magnification. Maybe you can. Maybe imagination fills in what eyes cannot quite resolve. Either way, Mars is ahead. Real. Growing. Waiting. 160 million kilometers now. Getting closer. The habitable environment requires constant maintenance. Filters changed, sensors calibrated, backups tested. Life support is redundant, with secondary systems for every critical function. Water recycling failure means switching to reserves and repairing primary. Oxygen generation backup means electrolyzing stored water. Carbon dioxide scrubbing has chemical and mechanical options. We practice failures, drills, responses. Not with fear, but with professional calm. If something breaks, we fix it. If it can't be fixed, we use the backup. If the backup fails, we improvise. We're prepared. Elon Musk presented the Interplanetary Transport System, later Starship, in September 2016. He said, "I think there's a strong humanitarian argument for making life multiplanetary. A second planet would be a hedge against something bad happening on Earth." This mission serves that vision, not escaping Earth, but expanding from it. Learning to live on Mars doesn't mean abandoning home. It means giving humanity options, backups, futures plural instead of singular. We carry Earth with us in memory, in connection, in purpose. We go to Mars as Earth's ambassadors. Three months into the journey, halfway point approaches. 129 days down, 130 to go. Earth and Mars equidistant in different directions. The Sun dominates the sky, still brilliant, though slightly dimmer than from Earth. We're farther from the solar warmth. Temperature calculations show we're at 1.2 astronomical units now. Neither Earth's 1.0 nor Mars's 1.5, but between worlds. This is the most isolated humans can be, farthest from both origin and destination, deepest into the crossing. And you feel fine, calm, patient. China's Tianwen-1 mission launched July 23, 2020. Arrived at Mars February 10, 2021, after a 202-day transit. Successfully deployed Zhurong rover. International Mars exploration continues. NASA, ESA, China, India, UAE. Every space agency looks to Mars. Cooperation and competition drive progress together. Our mission builds on all this precedent. The trajectory Tianwen-1 followed, we follow. The orbital insertion Zhurong's mothership performed, will perform. Humanity learns collectively, mission by mission, building toward permanent presence. Daily life aboard involves small pleasures, a particularly good meal, a clear view of stars through a clean window, a message from home arriving just when needed, watching water droplets float in zero-G, perfect spheres held by surface tension, the satisfaction of repair completed successfully, sleep in the sleeping bag, cocooned and floating. Dreams are vivid in space. You dream of Mars sometimes, of arrival, of walking on red soil. You dream of Earth too, of gravity, of wind, of rain. Both worlds wait. For now, space surrounds you. Four months into the journey, Mars is visible without magnification. A small but definite disk, red-orange. No details yet, but unmistakably planetary. Earth behind is now just a bright star. You can hold up your thumb and completely hide it. 300 million kilometers separate you from birthworld. 40 million kilometers remain to destination. The ratio shifts daily. Earth recedes slower now. We're moving in similar orbits. Mars approaches faster. We're catching up to its slower velocity. The mathematics of transfer orbits made visible. Hohmann's ellipse traced in real motion. Mars arrival velocity will be approximately 5.5 kilometers per second relative to Mars. Must be reduced to 3.4 for orbit insertion, or further for direct entry. That's the next major burn. 2.1 kilometers per second delta V minimum. More if we choose higher orbit initially. The Mars orbit insertion burn is critical. Miss it, and we fly past Mars into solar orbit. No second chances. But we won't miss. Navigation tracks our position to meter precision. The burn will be exact. We trust the mathematics. We trust the engineers. We trust the spacecraft. Mars's sphere of influence extends 577,000 kilometers from the planet's center. At that radius, Mars's gravity dominates over the Sun's. We'll reach it 2 to 3 days before orbital insertion. That boundary crossing will feel like arrival, even though Mars is still days away. From Sun's domain to Mars's domain. From interplanetary space to Mars space. One more transition in a journey of transitions. From Earth to cislunar. From cislunar to heliocentric transfer. From transfer to Mars influence. Each step carrying us forward. The spacecraft has been home for 4.5 months now, longer than most days anywhere except childhood houses. You know every surface, every smell, every sound. The hum of life support is your heartbeat. The curve of the habitat walls is your horizon. The crew members are your family, chosen by mission planners but bonded by journey. You've shared meals, conversations, repairs, emergencies, drills, laughter, quiet moments. 6 humans crossing space together. When you arrive at Mars, you'll miss this traveling home. But not yet. Still days of journey remain. Perseverance rover and Ingenuity helicopter arrived at Mars February 18, 2021. After 203 days of journey, they landed in Jezero crater. Ingenuity demonstrated powered flight in thin Martian atmosphere. We watched those landings from Earth. Celebrated robotic success. Now we follow the same trajectory. Our landing will be different, larger, human, but the principles remain. Enter the atmosphere, survive heating, deploy parachutes or fire engines, touch down safely. Rovers tested it. We benefit. Always, the missions build on previous missions. Five months into the journey, Earth is barely distinguishable from other stars. You have to know exactly where to look. A faint blue point. Mars fills the forward view now. Not large yet, but definitely a world. Orange-red disk showing subtle shadings. You can almost see surface features. Dust storms perhaps, ice caps maybe. Still weeks from orbit, but the destination is real, tangible, waiting. We're coming to you, Mars. Patient and determined, following physics across the void. The final weeks of transit involve preparation for arrival, equipment checks, landing sequence reviews, communication protocols with Mars orbit infrastructure, if any exists. Everyone's tasks clarify. The transit phase ending, the arrival phase beginning. You review surface operations plans, where we'll land, what we'll explore, how long we'll stay. Months on the surface. Then return journey. Another 8.5 months following another Hohmann transfer back to Earth. The round trip takes 2 to 3 years. We're 1/3 done. Mars waits at the 2/3 mark. The entry interface altitude at Mars is 125 kilometers above surface. We must target a narrow 10-kilometer corridor for safe capture. Too steep, excessive heating. Too shallow, skip off atmosphere back into space. Navigation will be precise. Our trajectory has been refined over months of mid-course corrections. We'll hit the corridor center. The mathematics guarantee it. Then atmosphere does the work of slowing us. Or engines, depending on arrival mode. Either way, we transition from space to planet. From travelers to arrivals. From voyagers to explorers. Seven months into the journey, Mars dominates forward view. A world now, clearly defined. Polar ice caps visible as white points. Dark regions and bright regions, suggesting terrain variation. You stare at it for hours. That's where we're going. That alien world with its thin carbon dioxide atmosphere. Its ancient riverbeds, its towering volcanoes and vast canyons. Humanity's next home. Temporary, yes, but home. We'll walk there, plant flags, conduct science, establish presence, and eventually, others will follow. Mission after mission, until Mars is not alien anymore. The spacecraft systems continue their patient work. Recycling, monitoring, maintaining. 7 months of flawless operation. Minor glitches resolved. Backups never needed, but always ready. The engineering holds. The design functions. Decades of mission planning vindicated by this sustained performance. You trust the spacecraft completely now. It's kept you alive across 180 million kilometers of radiation and vacuum. It will deliver you to Mars orbit safely. You have no doubt. 8 months into the journey, final approach begins. Mars looms large now, filling the window. You can see Olympus Mons, the solar system's largest volcano. Valles Marineris, the canyon that would span North America. Details emerge daily. This is not telescope astronomy anymore. This is direct observation. We're here. Almost here. Days remain, then hours. Soon the orbit insertion burn. Soon capture by Martian gravity. Soon the planet we've traveled 259 days to reach welcomes us into its embrace. You prepare for arrival by reflecting on departure. 8.5 months ago, Earth filled this window. Now Mars does. The journey between feels both infinite and instant. Days blending together, yet each one distinct in memory. You've changed. Everyone has. You've learned patience, cooperation, self-reliance. You've learned to live away from Earth, to trust systems, trust crew, trust trajectory. Mars will teach new lessons, but this transit taught the first one. Humanity can cross interplanetary space. It's not easy, but it's possible. We're proof. The night before Mars orbit insertion, you float in your sleeping quarters. Unable to sleep, too excited, too calm, too everything. Through the small window, Mars rotates slowly. Cloud formations, dust storms, ice glinting at the poles. The world will orbit tomorrow, then descend to, then walk upon. This journey of 8.5 months culminates in arrival, but arrival is just another beginning. The mission continues. The exploration starts. The learning deepens. Mars waits with patient, ancient secrets, and we're ready to listen. The spacecraft hums around you. Life support, recycling, water, oxygen, breath. Solar panels tracking the sun. Gyroscopes maintaining orientation. Outside, Mars waits. Inside, warmth and safety. The presence of fellow voyagers sleeping in nearby compartments. "259 days from Earth to Mars." Not 258. Not 260. The mathematics patient and exact. we followed the ellipse. Hohmann's century-old calculations carried us across the solar system. And here we are. You are farther from Earth than any human has ever traveled. 350 million kilometers. And you're going further still, down to the surface, into Mars's embrace. But not tonight. Tonight you rest between journey and arrival, between Earth and Mars. The spacecraft protects you. The trajectory carries you. Sleep comes naturally. Deep space cradling you gently. Outside your window, Mars rotates, orange and red and ancient. Tomorrow's world, tonight's view. You watch it turn, peaceful, patient. Your breathing slows, heart rate settles, the journey's end approaches. For now, floating, comfortable, safe, held by the spacecraft's gentle embrace. Mars is not impossible. Mars is inevitable. And tonight, we sleep between planets, carried by mathematics and momentum. Toward the next world, humanity will call home. The red planet grows, week by week, month by month, now, hour by hour, soon, minute by minute, but not yet. Rest first. 225 million kilometers behind you. A few thousand ahead. The crossing nearly complete. The arrival imminent. The mission continuing. Sleep. Stars surround everything, brilliant and steady. No atmosphere to make them twinkle. Pure light. Ancient light. Traveling years to reach your eyes. Beautiful. The sun smaller than from Earth, but still bright, still warm, heating the solar panels, powering the habitat, sustaining you, constant. You close your eyes. Mars remains visible behind eyelids. Orange afterimage. Tomorrow's destination. Tonight's dream. Rest comes. Peaceful. The crew sleeps around you. 6 humans, 6 dreamers. All traveling together. All arriving together. All exploring together. Community. Your breath synchronizes with life support hum. Inhale. Exhale. Oxygen provided. Carbon dioxide removed. Perfect balance. Sustained. Microgravity holds you. No weight pressing. No gravity pulling. Floating. Free. Suspended between departure and arrival. the tween. Tomorrow, Mars orbit insertion. The final burn. Capture. Tonight, traveling. Still moving. Still crossing. Patient. Eight 8.5 months, 259 days, 6,216 hours, all leading here to this moment, this quiet rest before arrival. The trajectory is set, cannot be changed now. Physics carries you forward. Trust it. Trust the mathematics. Trust the journey. Sleep. Mars waits, patient as stone. 4.5 billion years old. It can wait. One more night, while you rest, peaceful. You are safe, protected, held. The spacecraft your home, space your passage, Mars your destination. All certain. Sleep now, deep and peaceful. dreamless or dreaming. Either way, resting, restoring, preparing, ready. The void holds no fear, only peace, only quiet, infinite and gentle, surrounding you, cradling. Stars above, Mars ahead, Earth behind, all connected, all part, all home. Your heartbeat slows, calm, steady, life continuing, simply, peacefully. Tomorrow comes, eventually, always, for now, tonight, rest. Floating, weightless, free, between worlds, between moments, between. The journey, almost complete, almost, but not yet, still traveling, still. Mars turns orange, red, beautiful, ancient, waiting. You drift toward sleep, toward dreams, peaceful, safe, held. The spacecraft, humming, constant, life, sustained, continuing. Deep space, all around, infinite, gentle, patient, eternal. deep sleep, peaceful, restful, complete. Now, Mars. Tomorrow. Tomorrow. Tonight. Sleep. Sleep. Floating, peaceful, safe, between, always, rest. Stars, brilliant, steady, watching, constant, beautiful. Rev. Slow. Calm. In. Out. Peace. The habitat darkens. Night mode engaged. Amber light. Soft. Warm. soothing. You settle deeper into the sleeping bag, restraints gentle, cocooned, protected, comfortable. Mars outside, rotating slowly, always there, patient, waiting, close. The journey. Nearly done. Tomorrow, arrival. Tonight, rest, peace. Your eyes heavy now, closing. Darkness, comfortable, safe. Dreams begin. Mars surface. Red soil. Walking. Exploring. Soon. The spacecraft, your guardian, faithful, carrying you, protecting you, always. $259 days. Complete tomorrow. Tonight rest. Sleep. Deep. Peaceful. Mars gravity. Tomorrow you'll feel 0.38 G. Tonight, weightless, floating. The void. Beautiful. Infinite. Home. For now. Rest. life support, breathing for you, constant rhythm, oxygen, water, life. You drift, consciousness fading, sleep approaching. Peaceful, natural, complete. Mars, waiting, patient, ancient, red, home. Stars eternal, light years distant, watching over, constant, forever, beautiful. Sleep now. Complete rest. Tomorrow, Mars. Tonight, peace. Sleep. between worlds, between moments, floating, safe, held, rest. Deep space, cradling you gently. Sleep, dream, peace. Tomorrow arrives, but not yet. Rest first. Sleep deep. Now. Mars, tomorrow, tonight, sleep, peace, rest.